Good afternoon. Thank you for joining us today. My name is Ranvijay, and I'm joined with Cody. We are program managers in Azure Machine Learning. Before we get started, can we do a show of hand? How many of you are data scientists in this audience? Right, thank you. And how many of you are working with computer vision? Right, thanks. So yeah, that's helpful. That will help us in keeping the context right. So let's talk about Azure AI. If you look at Azure AI, there are three main pillars of Azure AI. One is AI apps and applications. These are pre-built applications and models such as custom vision, forms recognizer, bot framework, and things like that. Tools for developers that you can use to build applications around it. The second one is knowledge mining. You can use cognitive custom search capabilities to do knowledge mining on the knowledge base that you have within your organization, like documents and videos and things like that. And the third one is machine learning. The machine learning allows you to build custom applications and custom models on your own. This session is going to be about machine learning. Right. There are four key value propositions of machine learning. Right? One, it's open and interoperable. What that means is that all the open source framework and the technologies that you are familiar with, the popular ones, you can use those within Azure Machine Learning. The second, it's trusted. And by trusted, we don't only mean the privacy and security, but also things like model transparency or explainability. The latest technologies in transparency and explainability are available, and you can access those right from Azure Machine Learning services. We have industry-leading ML ops. Just like for software, you have DevOps. For machine learning, you need similar capability for continuous training or continuous deployment and monitoring. So you can use ML ops to do such kind of things. And the last, in the Azure Machine Learning, you have tools for data scientists of different skill levels. Like if you are someone who is very new, have some idea about data science, you know how to work with the data, you will be able to use automated ML to train a machine learning model and get some results out of it. If you are at the next level where you have more detail, more information about what these models are, what algorithms are, and you want to do some drag and drop and try out a few different parameters and options, you can use our designer, which is a drag and drop experience to build machine learning models. And if you are someone who wants to get your fingers dirty, write code from scratch and have some complete control over it, then you can use the notebook VMs that come with Azure Machine Learning or your favorite IDEs or anything. This is a quote from one of our customers and how excited the customer is about the ML ops and the fact that the customer can retrain models in minutes rather than days that it used to take them earlier. Right? So this session is about managing and preparing data for computer vision. If you look at the typical machine learning cycle or life cycle for computer vision, this is what it looks like. You start with the data, you access your data, and then you need to label your data before you can train a machine learning model. By labeling means you might have seen that given an image, you want to say that this is where a particular object is, or maybe the classification of the image, what class that the image belongs to. You might have seen those images. So you need to do that part before you can actually train a machine learning model. And then you train it, you deploy and serve, and you monitor the performance of the machine learning model in production, and you iterate over it. All throughout the life cycle, you need to have access to the data. You need access to the data while you are training the model, while you have deployed the model, or while you are monitoring it. So in this session, we will talk about the first two parts, that is accessing your data using datasets, Azure Machine Learning datasets, and how it makes your life easy. And second, we will be talking about labeling data. We will label the data, and then we will take the labeled data to a notebook, and we'll walk you through the code using which you can train a machine learning model. So with that, let me invite Cody to talk about data sets.
Thanks for having me. So as we discussed, in the machine learning lifecycle, we almost always start with data and training that data to produce a model. So we just introduced at Ignite the general availability of our Azure Machine Learning datasets, which make it very simple for you to do this at scale.
Mike's not.
Run out of battery. Hello.
There you go.
Cool.
Just full. I'm not sure why it's shutting off. I'm using some fresh ones though.
We good now? Okay. I'll stand over. Try not to move it around too much. So let's talk about Azure Machine Learning datasets, which allow you to train both locally and across distributed compute at scale. The green light is on. We're getting a mic. I should have practiced my stand-up routine a little more. Do you need the mic off? Hello, testing. Cool. We got there. So let's take a look at what Azure Machine Learning datasets are. They take data from any of our popular Azure locations, such as blob storage, data lake, Gen 1 or 2, Azure SQL, or you can use ADF to move data from anywhere, including somewhere even like Amazon S3, into Azure so that you can use them natively in the Azure Machine Learning service. This allows you to, as you see, train both in your local environment, or once you're ready, move to a hosted notebook VM, or even scale out to distributed nodes through Azure Machine Learning clusters. These can be powerful Azure VMs, including things like GPU machines, such as the standard NC6, which we'll use in our demo today to show how you can use PyTorch to easily train a CNN on a labeled dataset. I am going to kind of rush through these slides and mostly want to spend time kind of demoing the datasets and showing you the power of them. So datasets you can create from a data store in the Azure Machine Learning service. They allow you to keep a single source of truth, protect your sensitive information. We just launched RBAC support, so you can control exactly who has control and access to these datasets. And the other thing is that they allow you to track the lineage throughout your machine learning lifecycle, so you know where your data was used and you can reproduce those models. This is important in a production machine learning setting, where I need to know exactly how my model was trained so I can go back and explain it and have the auditability. The other thing datasets allow you to do is very easily access them from anywhere in Azure Machine Learning, whether you're using the drag and drop UI called the designer, automated ML, or in any code. So this is a code that we'll see and run through in a bit. It's just a few lines, and you can get access to that data set. So you don't need to put your credentials in a string. You don't need to have credentials in your code, and you can access it from anywhere. Again, we also embrace open source, so you can convert these data sets into any type of data frame, whether it's Pandas or PySpark, as well as convert them to native TensorFlow or PyTorch data sets. And again, one of the key value props is that data scientists tend to start developing locally using just a small sample of their data set. You can do that with our data sets, use them natively locally, and then scale them out across compute clusters when you're ready to really start scaling up your training. The other key thing, of course, is that you can track your lineage across your machine learning experiment. So you can see that here. You input your data set into an experiment, and it gets tracked through to your model. So to recap, you can take data from anywhere, use whatever tools you feel comfortable training with it, convert it to popular open source frameworks, and have all of the benefits of a secure and reliable dataset service. You may see in some of our other demos or slides this wacky datasets cheat sheet. I'm going to throw it up here so that you can reference it later, but it gives a very good overview of some of the common Python methods you'd be using with these datasets. But let's hop over to the demo and see how we use these things. This will be interesting with holding a mic. Sure. Cool, so let's pop over into the Azure Machine Learning Studio. If you're not familiar with this, we're on the home page right now, and you can scroll down and head over to our tutorials. This will give you a very good overview of anything you want to do in Azure Machine Learning, including a full tutorial on datasets right here in the middle. So let's head over to our datasets tab. I can see all of the datasets that I have in this workspace. Again, these are tracked in version, just like the models in the Azure Machine Learning workspace, and I can take them and use them anywhere. If I head into one, for instance, this Mls dataset down here, I'll see the models that I've used to train this dataset on, and have a link to it right there. I can jump to that model and easily deploy it or do whatever I want to do with it. Heading back to the Datasets tab, we also have these dataset monitors, which monitors for things like data drift. This is a already built data drift monitor. I can see I have my data drift magnitude. This is on some weather data, so it's very cyclical over time, going up and down. I can see which features contributed most to the data drift in this dataset. And I can zoom in on individual features and see their distributions and other metrics about them over time. Heading back to the Datasets tab, let's see how you go ahead and create one. I'll click Create Dataset. I can either create one from local files, from a data store, from web files, or from our curated open datasets. Clicking from a data store, I have to give this dataset a name. Choose what type it is, tabular or file. We'll go through the difference in a bit. And then choose my data store. I browse my path to my data. In this case, I have it under Florida weather data. And I've partitioned my data by year, and then month, and then day, with the final file being in a data.csv. This is an important thing to note. A data set doesn't necessarily have to be static. It can grow over time as you add more data. And we provide some very simple methods for accessing that data over time. So you can take the most recent, say, month of data, or the time between January 2019. Once I'm done, in this case, I'm just taking a single day of data, I'll go through this nice UI, which will automatically profile or show me a preview of the data. And I can go through and select the schema and modify it if I need to. Once I have this data set, it's here, and it can be used, again, in any of our authoring experiences, whether that's the designer. I see all my data sets here on the left-hand side. I can drag and drop them over, and then use any of my other designer machine learning tools to play around with that data set, transform it, or even train a powerful machine learning model on top of it. Similar story for the automated ML UI. I can simply create a new run and choose, again, one of those any same data sets to train an automatic machine learning model on it. Lastly, we can head over to notebooks. So I'll head over to one that I've created before. This is in our new notebooks UI, integrated directly into the studio. You can run these notebooks right here, or optionally, it's a little too zoomed in to see, but on the right-hand side here, we have the option to open it in Jupyter Lab. You see, there we go. So I can open this directly in Jupyter or Jupyter Lab. I've gone ahead and done that here. So let's take a look at how we can use datasets in a hosted notebook VM. And note that everything we're doing here can be done on remote compute as well, so you can easily scale this out. I'll go ahead and access my workspace using this very common code. If I'm a bit lazy, I can throw this in a config file and get it down to one line of code, which you should definitely do. After I have my workspace object, just like we saw in the UI and the other authoring experiences, I can go ahead and list all of my data sets that exist in that workspace. So we have that Florida weather data that we were looking at, as well as the other ones. Now to get a data set, I simply get it by its name, and there it is. I can convert it to a pandas data frame, which I'll do in this next cell, and print out the first 5 rows. Once I have it in a data frame, I can do whatever I want with it, using it in any training algorithm, or just doing some analysis of the data, such as taking a histogram of one of the columns. Run this twice. The other key feature of datasets is the file datasets. So these allow you to mount files that exist in Azure storage without needing to make a copy of the data. You can do this on any Linux-based compute, including our hosted notebook VMs or any of our training clusters. I have this domestic animals file dataset here, which contains a bunch of pictures of animals, which we'll be using later in our labeling and computer vision portion of the demos. I'm going to go ahead and get this dataset, just like I got my previous dataset. And then I'm going to mount that data set. So normally if you're training within a training file, you're going to do this with dataset.mount and then have all of your training code down there. So let's go ahead and do that and run os.lister and see what's there. Again, this is mounting to this temporary path here, and all of the data is mounted onto this compute. I'll take a second and show me that I have one directory here called cats, dogs, parrots. If I go ahead and look through this, I see that I have a few hundred images of various animals underneath it. If I want to use this mount in more of a Jupyter Lab type of functionality, in a more interactive mode, I can also set the context of the mount and then simply start it. This way I can iteratively go through and play around with the data until I'm happy with it and ready to create a training script. So I've started that mount. Let's go ahead and see what's under that cats, dogs, parrots folder. This will print out a large list of JPEGs. There we go. So we see all of the files that this is mounted. This goes on for a long time, so I'm going to go ahead and collapse the output. Now, I can demonstrate that we can simply access that image, again, without copying it over. We're simply mounted onto that data set, and I can use standard tools like PIL or matplotlib to open the image and then display it. So we'll see later in these demos how you can then use this to train a powerful CNN on this image data set after we go through the task of labeling it. So to go through the task of labeling this data set to actually prepare it for our training, I'll hand it back over to Ram Vijay.
Thank you. So talking about data labeling, data labeling is an important step before you can train a supervised machine learning model for computer vision. You have images, and you need to specify what is the expected output. Are you looking for objects? Are we looking to classify the images? And things like that. But why is it challenging? So actually, it's not. If you are talking about a couple of hundred images, you can download a tool from internet, load images in the tool, and start labeling yourself as a data scientist. You may have to iterate a couple of times, because what happens is that once you start labeling the images, you realize that your initial definitions of labels are not correct. The way you were thinking about it was not correct, so you may have to iterate. For example, if you have, let's say, an image of a car, and there is a person sitting in the car, and you can see that in the image, the question that may come in your mind is, are you going to label it as a person, or are you going to label it as a car? And actually, there is no right answer here. It completely depends on whether you are counting persons or you're counting cars, and what your business scenario is. So the same thing happens when you start labeling your images. You look at the images and suddenly say that, hey, I don't know how to handle this particular image. So you iterate and come up with a new definition of labels. And that's OK. So you can do that maybe 100 and 200 images. You train a model. Sometimes you get lucky, and you get a good result just with the few hundred images. But many a times, you realize that as a data scientist, you cannot do the labeling yourself. And there can be few reasons for that. One reason, the data volume is huge, and you need lots of labeled images to be done. You don't have time to do that. The second reason could be that you just don't have the domain expertise to do the labeling. If suppose you are doing some very specialized work, you are working in a manufacturing, quality control, and things like that, you as a data scientist may not have the expertise to do the labeling. And that's where you need help of other people in the labeling process. And the moment you need other people to do labeling, it starts getting complicated. And let's talk about the challenges that you will face when you are taking help of other people in doing the data labeling. Right. So the first challenge that you are going to face is about the data itself. Your data is lying somewhere. You may have millions of records, millions of images, and you want to make these things available to the people who are going to do the labeling. Right? Again, this is something that you cannot do with a desktop tool. It's going to be very difficult. Second, the tooling itself. You need a GUI-based tool in order to do the labeling. And it's not just any tool. It needs to be a multi-user tool that anyone can access. Right? And people, the domain experts, they will do the labeling at their own spare time. So you need a tool that they are able to access. The third is the workflow. Right? You need to distribute these data points to those labelers or the people who are going to help you, then collect it back. And also keep in mind the iteration thing that we talked about earlier. That thing is going to happen here too. So you need a way to iterate on your data labeling. And depending on the volume of data that you have and the number of people who are going to help you, it actually can become a very complicated project management problem where you need to optimize on the time and cost and how many people are working on it, and most importantly, the quality of labels. Because if the quality of your labels are not good, you are not going to get good models. So let's see how, and the last thing is the fundamentals. I mean, many of you, when you start working on these projects can be very sensitive in nature. It's something that you don't want other people to know about, your competition to know about. So all these things are very, very important. So how Azure ML Data Labeling does it? For data, we build on top of the data sets, the same thing that Cody talked about, and all the beautiful features and power of data sets come right here in the data labeling also. We provide you pre-built tools for labeling. These are multi-user browser-based tools that you can use very easily. We take care of the task distribution, and we also support iteration. So you can actually, while you are running a labeling project, you can pause it, you can make some changes in your configuration, and then resume it. You'll see that there are a few capabilities for project management right in the data labeling tool. We are going to give you a demo of that. And of course, the labelers, the people who are going to label your task, we are going to authenticate them using AAD or MSA account. So it's not limited to the people within your organization. If you have anyone, any vendor or interns or anyone who is willing to help you in the labeling process, you will be able to add them as a team or a labeler in your data labeling project, and they will be able to help you with that. And finally, in order to accelerate your labeling process, we are releasing ML Estate Labeling. And we'll talk more about that. The ML Estate Labeling is where the machine learning model helps you in the labeling process to accelerate the entire workflow. This feature is going to be in limited preview for some time. And if you are interested in participating in this preview, please contact us, and we'll work with you. So we'll do a demo of labeling, and this is what it's going to go like. We'll start with creating a data set. We'll create a data labeling project. As a data scientist, I will label data myself, and then we'll add labeler. I'll add one more labeler. We'll see how the other person can do the labeling. Again, I can check the quality. I'll see what is the quality. And then finally, I'll export the labels and hand it over to Cody, who will take those exported labels and train a machine learning model on top of that. So let me get started with the demo. So what you're seeing here is the Azure Machine Learning Studio. And on the left-hand side, you have Data Labeling tab. Once you click on that, you'll see the multiple data labeling projects that you have running. You can have multiple projects running, and you can also pause the projects or run the project as needed. Let me create a new project here. You provide the name of the project and specify what type of labeling it is. In the current version, we support 3 types of labeling tasks, 2 different types of classification, and 1 object detection using bounding boxes. Let me select object identification here. Go to next. It asks me to select an existing data set, or I can create a new data set. Since I already have a data set created, I'll just go ahead and pick the domestic animal ones. If I didn't have one, then it gives me an option to create a new data set inline. And here I add the classes, the label classes that I want to label in the images. So I know that in my image, I have 3 different types of animals: cat, dog, and parrot for demo purpose. Go next. Here, I can provide instructions to the labelers, the people who are actually going to do the labeling. It's a very important aspect because you are taking help from people who are remote or may not have an opportunity to talk to them. So it's very important that you give very clear instructions to them with positive examples and negative examples and different scenarios. You can either provide instruction in rich text box here, or you can provide a URL here and on that particular website, SharePoint site or something, you can upload a video or rich text or a PDF document, whatever you like. But if you are doing the labeling yourself, you don't have to provide the instruction. I'll just skip this part. And this is where you enable Mls Estate Labeling. Now, I'll not click this thing because this feature is not generally available today. It's not in preview. It's available to only selected customers. And we'll talk about Mls Estate Labeling and its capability a little later. I'll go ahead and create the project. That was not expected. So for some reason, let me see. Let me go back and okay. Maybe I'm missing something here, but I already have a project created, multiple projects created. So what happens is once you create a project, it goes into the initialization phase. At that time, what it does is it will go and parse your data store and start creating task items in the data labeling project. So let me pick one of the existing projects. This is something that we created earlier. Once you get into the project, you'll see a dashboard which says you how many items have been labeled already and how many are pending. You can look at a preview of the data. And as a data scientist who just now created the project, if you want, you can start labeling yourself. You click on Label Data, and it'll open a labeling portal where you can start labeling your data. If I go to tasks here, I see these images. And let me just, for the purpose of demonstration, label these. There are multiple cats. I'll just use them as a single box in the interest of time. And as I am doing that, back to this the studio, I can actually see the dashboard. In the dashboard, I can see the number increasing. It was 369. It may take a little bit of time because we are submitting the labels asynchronously. So you see that this number increased from 369 to 370. And suppose now we realize that I need to add more people to this project. So the way you can do it, you can go to the team. When you create a data labeling project, it creates a team by default. And you can add labelers to that. So I'll just add one more labeler here. I'll use this particular account that I have, the labelingta@outlook.com. Imagine this is a domain expert and who is helping you in the labeling process. So let me switch to a different window. And what you need to do is you need to share the URL of the labeling portal with that person. So if I go here in the project details, you will see the URL. So let me take this URL and go to another window. Once I go here, it's going to authenticate me. And I see the same portal here. Now imagine you have a team of people helping you in the labeling process. They can all work in parallel. So I'll skip the labeling part here because this is the same experience that you saw earlier. And from here, you can, this is your portal, the studio. From here, you can see the label data, the data that has been labeled by other people, right? So these are you can just navigate through it. And this is the place from where you can also do quality control. If you don't like a particular label for whatever reason, let's say the label is not drawn correctly or it's not tightly drawn around the object, you can reject it. Once you reject it, it goes into the pool of unlabeled data, and then someone else will pick it up and do the labeling. This is the current version. In future, you can expect that we'll have more sophisticated quality control on this. Now, at any point during the execution of this labeling project, what you can do is you can export the labels. We allow you to export the labels in two formats for images. One is COCO. It's a popular label storage format for images. And the second is as Azure ML Data Set. Once you create it as Azure ML Data Set, again, this becomes one of the data sets, just like other data sets, and you get all the benefits of data sets. So while I'm doing that, let me talk about ML-assisted labeling. So as I said, this feature is in preview right now, and the link is there, the email address is there here in the slide deck. So you should be able to contact us if you want to participate in this thing. And let's see how it works. So suppose you have unlabeled data, say 100,000 or millions of unlabeled data. We have a task creator component that will create tasks, or what we call unlabeled tasks. Now, human labelers will come, and they will start labeling these tasks. As they do that, what you get is the label data. And this is the part that we demonstrated just now. Once you have label data, you can export the labels at any point in time. But at this point, once we have few hundreds of label data, we do something interesting. What we do is we start training a machine learning model in the background. Now, expectedly, you can expect that the quality of this machine learning model, the accuracy is not going to be very high because it's been trained only on 300 images. Still, we can use the output of this model to do something very interesting. We can cluster the task. We start putting similar images together, and we start giving clustered images to the labelers. Now, this avoids the context switching and cognitive load for them, and they can do labeling much faster. So this is what the clustered tasks look like. So this is a classification scenario in which a labeler can look at multiple images at the same time and say what class it belongs to. And if you notice here, this comes from MIT's indoor data set. And if you notice here, most of these images are actually warehouse images. A couple of them are not. So it's relatively simple for the person who is working on this to just select multiple or select all, just remove a couple of those, and then label. Now, this thing continues for a while, and then what happens is the ML model matures because we are iteratively training the model. As we get more and more label data, we are training the machine learning model. The model matures. When the model matures, then we start producing pre-labeled tasks. What that means is now the images that they were getting, the labelers were getting empty images earlier. Now they see labeled images. And now their job changes from creating the labels to reviewing the labels, right? Let me show you what it looks like. In this particular case, again, it's a classification, same data set, and all of these are pre-labeled with Subway because they are. and the labeler just need to review it, select all, and submit. This accelerates the entire labeling process significantly. We have seen significant improvement in the labeling time taken and quality when we did our experiments here. Now, we continue doing this thing. This thing continues till all of your unlabeled data has been labeled. Then you can export those labels. And then I'll hand it over to Cody to show you how you can use the labels that we exported to train a machine learning model.
Thanks, Vijay.
I'll do this again for you.
Thank you. So let's head back into the Azure Machine Learning Studio. I'm in the same workspace that we just saw Vijay running through the labeling tasks in. So I see my labeled data sets here. My original was this domestic animals, and my new labeled data set is this one with the detection tag on it. I'm going to jump straight into the Jupyter Lab and show how you can now use this data set to train a CNN. Actually, let me take a step back. Let me show you first how we can create a notebook VM based on a GPU VM in Azure, which we can do to speed up this training process. For the purpose of this demo, we want to use a GPU machine, which unfortunately is not available in this workspace. So let's jump over to one of my other ones. I'll go ahead and create a new notebook VM, give it a name, and choose my VM size. So we get a plethora of options here, ranging from very low-cost general purpose machines up to much more high-scale GPU machines here toward the bottom. The one I'll be using is the standard NC6, which is a pretty good base GPU machine to get started with. After that, all you do is click Create. This will take a few minutes to spin up the notebook VM, and once it's there, you'll have these URIs where you can access a notebook VM. You could also go ahead and SSH into this just like any other VM. I tend to go ahead and open this in Jupyter Lab, which I have here on this existing Kodi GPU notebook VM. So heading into there, let's see how we can use that data set that we just labeled to train a CNN using PyTorch. Fortunately, there's not a ton I have to do. I just took some existing code from one of the PyTorch examples, made very few modifications, added some Azure ML code for tracking, and it just works. I can also scale this out or submit it to remote compute. Depending on my task, I may or may not be able to scale it across multiple GPUs as well. So let's go through the code. I'll start in this demo.ipynb, which runs through everything. First off, I'm just going to access my workspace. This is the same, again, same labeling workspace that we were using. And then I'm going to get my data set here, that same detected data set. Now I'm simply going to call labeled dataset.toTorchVision. This converts my labeled dataset into a PyTorch dataset that, again, I can just use natively in any PyTorch training code, which is what I've done here below. I'll go ahead and run this. Now again, it looks like I typed set twice. There we go. So now I have my labeled dataset as a PyTorch dataset. Next, again, I added a little bit of Azure Machine Learning code here just to make sure we're tracking all of our metrics, our inputs to the training code, and so that I can register the model with the Azure Machine Learning workspace and get all the benefits of our ML ops workflows and everything else you can do in the Azure Machine Learning service. I'll create my experiment and call it labeled dataset training on PyTorch. And then I'll define my Azure ML run. This is a local run that I'm just doing in this notebook VM. I could also use something like an estimator to submit this to a remote compute with very little to no modification to my code. So all I've done is wrap this PyTorch code in a little function here where I can easily play around with the parameters that I'm using to train this model. I start off by logging my parameters and inputs to my workspace. We'll go ahead and see that in the portal in a minute. And then most of this is just that standard example PyTorch code. So loading in Torch Vision, loading in this fast CNN, getting the features, and creating the model. Of course, I want to benefit from the power of a GPU, so I'm going to turn my device onto CUDA if it's available. Otherwise, I'll use the CPU. I'll go ahead and log this to the workspace as well so that I know whether or not I trained on a GPU. Again, back to standard PyTorch code here, setting up the data and sending the model to the CUDA device. I'll set up my learning rate scheduler. And I'm going to output our standard output to a file so that it's captured in our run snapshotting and uploading capability so that I can track it later in the Azure portal. This means that I've tracked all of my experimentation so I can see what I used as input to the training as well as what the output was. Looks like we're running into some internet issues here. Now below, I'll simply call this training script, which exists in this engine.py. After that runs, and we'll dig into that in a second, I'm going to save my model as a standard PyTorch model, upload that standard output, and upload the model file. Optionally, I could go ahead and register this model here in the run. You don't necessarily want to do this every time. You should look at past models and compare them for accuracy before you register a model and make sure that it beats out your previous ones. But just for the sake of demo, I will register the model every time. And then I'll complete my run, as well as catch any errors so that I know where I messed up. Now, I just have below this a simple cell that sets up my parameters and calls that function above. So as a data scientist, I can go ahead and play with these parameters and tune them either based on my existing knowledge, previous experience, or just randomly guessing. We also have some hyperparameter tuning features in Azure ML that can go ahead and do this process for you. So once I run this, this will kick off the job, and we can see the results of the training in the Machine Learning Studio. I don't think this will actually run because of the connection issues we're reaching, but we'll go check it out in the studio in a second. Heading into the engine.py, I can see my training script here. I've made no modifications to this. This is taken directly from a PyTorch example, which again is part of the power of Azure Machine Learning overall. You can take these existing frameworks, existing code, make minimal to sometimes even no changes, and get them running on Azure Compute with all of the benefits of tracking your experimentation, integrating with Azure DevOps, and all the other cool features that Azure Machine Learning gives you. So let's head over to the studio and see what we have. If I head to my experimentation tab, I can see that I have 2 runs of this before. Both completed. The first one I only went through 1 training cycle, so it only took about 5 minutes. And the second one went through about 10, so it took about 50 minutes. If we head into this second run, I can see all my various metrics that I logged. So now I know what I did, and I can easily track my experimentation. I've seen data scientists like building spreadsheets and just writing it down on paper. So this is a huge improvement that you can use very simply to just get your basic tracking in. Also, we'll see that model that I registered here. So I can go ahead and just click into that model, which was registered from the run. From this model, I can deploy it through Azure ML, either as a web service endpoint or do powerful batch inferencing using our new batch inferencing service. We have a even have a deploy button through the UI that you can use. Looking through this, I have my metrics. If I had, for instance, an accuracy chart over time, I could display that as a chart. I have any images which I logged. I didn't do that for this run. And I also have those outputs. So this is the output of that training. I can go ahead and look through it and get a sense of what my precision and recall was. Since this is a object detection bounding box type scenario, I don't have a normal accuracy of like 90%. I have to look at my precision and recall across various different views of the data. So I can go ahead and do that and decide whether or not I want to promote this model or what I want to do with it. I also take a snapshot of all of that code, so it's all tracked here. And if I were working in a Git repository, that's tracked as well. So the model is reproducible. I know exactly what I did to train it, because all the code is here. And it's sitting in our Azure Machine Learning model management service, so you can use it all across our service. And that's the demo. So I'll hand it back to Ram Vijay.
Thank you, Corey. Can you switch the display? So that concludes our session for today. We talked about Azure Machine Learning in general, and then we talked about data sets and what kind of benefits data sets bring to you. And then we looked at the data labeling capability that we are launching at Ignite and how you can take help of domain experts to label your data. We showed how you can take the label data and train a machine learning model using this. So here are some session resources. It will be part of the slide deck, so if you want to access it later, you can do that. There are some of the other sessions. Perhaps the only one that's left is tomorrow's session in Azure Machine Learning. Please evaluate this session and send your feedback. Thank you so much. Thanks for coming. And if there are some questions, we can take it after the session. This is over. Right. Okay, thank you.